Let's see, there we go. Well, good morning, everybody. That panel was awesome, really cool. But first of all, before I get started, I want to thank the organizers for putting this on. Ashish, Pravan, Nikhil, and everybody else that does this. This is a lot of work that they do, a labor of love that they do. They volunteer doing this. So a round of applause for the organizers for this. So I'm just going to take a few minutes to talk a little bit about how Postgres is used at Amazon. Amazon's a bit of a bigger company, and it uses a lot of data. But going back to the beginning of Amazon, when it used to be just a bookstore, it was an Oracle shop. And as it grew, it started using more and more Oracle over the years. And then 2006, AWS started. And hearing from customers, they want to be able to store their data in databases. So you get things like SimpleDB, which worked for some people, but people still like relational databases. So RDS was launched in 2009 with MySQL support. And then subsequent from there, you had Oracle and Microsoft SQL Server in the following years. And then finally, in 2013, Redshift was launched. This was the first bit of Postgres that was kind of out there because Redshift is based off of Postgres. We saw in Peter's keynote yesterday about how Postgres has a license that's very good for businesses. It allows you to take pieces of Postgres in there. Started out from a data warehousing perspective. You have made it very simple for people to start storing their data and using data warehouses. But about a year later, we finally get RDS for Postgres. In version 9.3.2, had pretty decent sized instances at the time, 88 vCPUs. Started out with 21 extensions. Those were primarily the ones in Contrib, but it also had PostGIS in there. But starting to learn about Postgres and running that in larger scales. 3 years later, Aurora for Postgres was launched. Big innovation there is separating out compute from storage. More and more solutions are doing that now, but at the time it was pretty innovative. That was in Postgres 9.6.1. But that's really when you were able to do different things with Postgres inside of AWS. But those three services provided the key to do something really cool, was move Amazon off of Oracle. So Amazon was one of the biggest Oracle users out there. And over the course of about a 2-year project or so, all of Oracle was moved onto primarily the Postgres databases. There's some Dynamo in there and everything else, but 7,500 databases, and it wasn't the same database 7,500 times. There were very distinct applications. And it was over 75 petabytes worth of data. It was, I joined AWS in the middle of this project, and I got to train a lot of people on Postgres, old Oracle people on how they use Postgres, and seeing the process and how Amazon was able to do that from the consumer side of really having a top-down mandate that even at the C-level, everybody was like, no, we're moving the Postgres, and it was the primary thing to do. So even to today, whenever you're doing things on Amazon in any of the infrastructure, more than likely you're touching Postgres along the way, right? It is the primary relational database used throughout Amazon. And that just continues to grow, right? But what that did was created an awesome thing. So at AWS, we like to talk to our customers and find out what they want. Amazon.com, the retail side, from an AWS perspective, we consider as a customer. And they're a very special customer because they could just come over to our desk, right? So for good and bad, we heard a lot of feedback from them, and it drove a lot of innovation internally in seeing what they do because as you can imagine, the retail site has to be able to have scale and uptime, and it was very demanding. So it drove a lot of innovation of what came afterwards. Right? So Redshift today, a lot of what we heard from customers is it was great storing the data all inside of Redshift, but they wanted to be able to have the data everywhere else. So whether it's in S3 and other places. So from just having like petabyte scale, now having exabyte scale access to your data. RDS, going from that single version that we had, 9.3.2, now being able to support all the different versions along the way, right? Even when we're supporting older versions with extended support, supporting 11.22 through 17.4. One of the things that we're pretty proud of is how quickly we stay close to the community when they do the releases. For 17.4, when the community released it with that special release because of the regression in there, within hours it was available to customers. And across 114 availability zones in 36 regions. So having the mechanisms in order to be able to push that out really quickly was one of the things that we make sure that we stay very, very tight and close to the community to be able to do that. Other things we're doing there is around more extensions. More and more people want more extensions. The great thing about the Postgres community is there's a lot of them. The bad thing is there's a lot of them, right? And you know, we hear from customers all the time, I want this extension, I want that extension. You have to be careful on those because sometimes people write them and then they get a different job and they get abandoned and other things. So we're very selective on how we add them, but we have 92 of them now, and there'll probably be more in the future. Around Aurora, this is where we do a lot of innovation. Around limitless, where we do automatic sharding. We worked with the compute side to be able to do really cool things around synchronizing time across distributed systems. So we could use time for transaction IDs in order to get snapshots across a distributed database for limitless. Serverless too, we worked with the EC2 team to get a special EC2 instance type that scales up and down. So this way, as you have variable workloads, your database automatically scales with it. And global database being able to give you that high availability across regions and across the globe. So this way you have a target in order to be able to fail over, and doing that at the storage layer so you're not impacting your compute on your primary. So as I was mentioning that we're staying close to the community in order to get that release out the same day as the community. One of the things we did about 3 years ago is we started the Postgres contributors team. Joe Conway over here is the manager of that team. And there we're forward-looking, looking about where Postgres needs to go for our customers to get there. So they're solely focused on upstream contributions. Right? They all are our eyes and ears in the community. So that when they're saying, hey, there's going to be a special release, the team is ready to go on things like that. So there's, our internal developers can't follow hackers. Those guys do every day. That's where they live. But they're hey, this is coming, that's coming. We're able to get that, which keeps everybody in sync and being able to do that. At this point, there's 9 major contributors on the team. 7 of them are committers. And we do other things there besides just coding. The sysadmins, there's 2 sysadmins. We're handling the infrastructure of the Postgres community infrastructure. On the security team, we have the maintainer, the JDBC driver, trying to be able to do good things in the community and push it forward. So some of the things we did for Postgres 17, and a lot of that came from customer feedback, improving the performance of B-trees and various different things. Customers always want their queries to go faster. Collations. For those of you that went to Joe's talk yesterday, collations is a problem with Postgres when you're thinking about it coming from the operating system. Adding a default collation that's tied to Postgres and not glibc or ICU. So this way, your indexes don't become corrupt when you update your operating system. Right? It also had a really big performance gain on that. Then logical replication slots for failover, not having to resync your logical replicas when there's some sort of failure event. Something there to, as more and more people use Postgres as its source of data and feed other downstream systems, that became critical. But looking forward, some of the things that the contributors team is doing when they're thinking about where Postgres needs to go, we're hearing from customers a few different things. One is more and more people have to have it always available. The idea of having a maintenance window for customers is basically going away for a lot of them, right? They can't handle any sort of restarts or downtime. Looking forward to the next generation hardware, where is that going? Can Postgres scale to use the hardware that's coming into the more commodity market? And the next generation workloads. So some of the things that the team was working on for Postgres 18, some of which has been committed, some is still hopefully gets committed over the next few weeks, is parallelizing some things in PG upgrade. One of the biggest sources of downtime for people is when they have to do an upgrade. And do a major version upgrade, that may take hours. So anything you can do in order to speed up that upgrade process, to reduce the amount of time for people to be down, is helpful. Along the same lines, when you're doing PG upgrade, it doesn't carry along the statistics. So after you upgrade to the new version, your database runs really slowly because it doesn't have the stats in order to generate good query plans. Being able to export the stats out of the old version, bring it into the new version, so right away you could start using your database the way it was before with the same plans. And then other things when we think about downtime is that the planned downtime is if you have to change a parameter in order to restart it. People don't want to restart their database, so they won't change parameters, even if it'll help make your database perform better. So being able to tackle any of those parameters that require a restart, because not only do you get the downtime for the, say, 1 minute in order to restart, if you have a shared buffer cache of 100 gig, it takes a while for your caches to get warm again in order to be able to perform. So it impacts front-end applications potentially for hours for a simple restart. So you don't want to restart for a parameter change at all, ultimately. So next generation hardware, one of the cool things that we have at AWS is we're talking to the EC2 team and the various chip makers in order to see what's coming next. One of the things that EC2 just released are the U7i instances. And this one has 1,920 vCPUs and 32 terabytes of memory. Postgres could run on that, but it's not going to use all those resources effectively. So what the team's thinking about is, what are the changes that have to go into Postgres now, so as those type of hardware becomes more commodity, Postgres is able to run on those sort of things. Because that's going to naturally happen. As we add more and more resources, it's easier to scale up than it is to scale out. It's, once you start going into distributed systems, even if it's just a simple read replica, you have to change things in your application to be able to use it. Much rather be able to scale up to be able to use all that horsepower if you can. Right? So the team's looking at different ways to be able to leverage that. And then next generation workloads, that's kind of what we were talking about in the panel before. Gen AI is at its infancy, so we can't really see the future of what's out there, what's coming. You need to be in a position to be able to handle it. But one of the things that we do know is that Postgres is already popular with PG Vector to be able to store embeddings. And when you think about what Postgres is really good at, it's storing people's data. So is Postgres in a position to store the embeddings of tomorrow? And kind of is, needs a little work. Think about the typical dimensions that you get from embedding now. It's 1,536 dimensions. That's 1,536 4-byte floats. So that's 6K for one column, for one piece of data. And Postgres's page size is 8K. So when you imagine the amount of dimensions going up to 4,096 or 10 or 20,000 dimensions in the coming years, fitting that inside of a Postgres page, everything's already toasted, so you're getting performance hits. What can we be doing in order to be able to handle that kind of data? Perhaps it's something of make it easier for Postgres to change its page size easily, right? Or maybe it'll have that as a column attribute or a table attribute for the page size, where right now it's a compile option. So those are some of the things we're thinking about for the workloads tomorrow. What does Postgres have to do today in order to be able to handle those? That's at least one where the future isn't as blurry, that we're going to see that coming in the next couple of years. Right, so focusing on PG Vector. PG Vector is a unique extension where it's primarily driven by a single individual, Andrew Kane, really good guy, really smart guy, but we talk to him pretty regularly of what we're seeing from our customers, so helping him figure out what are things that people are using around that, driving a few things around parallel index builds, which take a long time for large vector tables. Or the half vector data type, right? So instead of using 4-byte floats, storing 2-byte floats. So that 6K immediately goes down to 3K. So that solves part of the problem as they're getting bigger, but not completely, because as you get giving up more and more of that precision, answers change, so you don't want to give up too much of it. Or being able to have applications connect to it and use it more effectively. So adding binary support for the data type, so you don't have to serialize and deserialize it as you go from your application out into the database. And then other things we're doing at AWS, kind of looking more forward, this is in preview, is Aurora DSQL. From the get-go, it was designed to be a distributed database built on Postgres that allows you to have your relational transactional database be multi-region, multi-active across the world. So as we're looking forward over the next few years, as that goes into GA and more customers start building their applications for that distributed model, right? Because it's hard to take a database schema built for just Postgres community and put it into a distributed model without making some changes and fundamental rethink of how some of that is supposed to work. Because they behave differently. Even though they look and feel the same and they all speak the Postgres language, which is what we have across all the different offerings of Postgres along the way, they behave differently because they were all built differently for different purposes. With that, thank you.